Our next speaker will be Dr. Philip Stoddard. Dr. Philip, would you be able to share your screen? Dr. Philip is currently a professor at the Department of Biological Sciences, Florida International University, since 1992 to date. He has more than 70 scientific publications on different aspects, focusing on birds, fish, and mosquitoes. Dr. Philip is more than an academician. He was the mayor of City of South Miami, Florida for 10 years until 2020. He always brings forth his knowledge and information through media to the public. So today, we are very privileged to hear from Dr. Philip. We are eager to hear his view on Zika dengue control in the US. Dr. Philip?
Well, hello. Thank you for inviting me. It's wonderful, at least to be giving a seminar in Malaysia, although I didn't get the benefit of being able to travel and enjoy the food. As the introduction said, I was a biology professor who was also serving in public office when in 2016, Zika crossed the Pacific Ocean and wound up in Miami, Florida. And we had here in Miami the very first outbreak of Zika. And if you remember, the strain that made it across the Pacific picked up a gene complex that was causing tremendous neurological damage to unborn fetuses, and people were panicked, destroyed the tourist economy that year, and pregnant women left town. It was a very scary time. And so the Miami-Dade County has a mosquito control division contained within the solid waste division of the county. But even the governor got involved, and they wanted everybody to use the most powerful methods and insecticide they had. But the basic science wasn't there. People didn't know how to control Aegypti in Miami, in a truly urban area. The Florida Keys actually was far ahead of us. But with the word coming down from the governor that you had to use everything, Miami-Dade County threw the kitchen sink at these mosquitoes. And I, who was interested in mosquito control, was able to predict pretty much what was going to happen. And I'll show you what did happen and how this played out and what I think are the lessons from this story. So this was a paper that I published analyzing these data, and I can tell you that it made me extremely unpopular in the mosquito control community. People did not want to hear what I had to say. But this was the area, part of Miami, where Zika first appeared. And this is an area that's very popular with tourists just north of the downtown. Lots of restaurants and sidewalk dining. And that's probably where and why it got started. So what the county did was they applied Naled organophosphate over a very wide region. And then within the smaller section, they applied BTI as well. And it was done with initially from the air, and then they brought in buffalo turbines and trucks and blew it up into the air. So it wasn't the experiment I would have designed, but it does give you the possibility for some sorts of comparisons. Not surprisingly, Zika then showed up in Miami Beach on the other side of Biscayne Bay in the south end, South Beach it's called, which is the most popular with tourists. They applied ester pyrethroids, they applied the organophosphate Naled, and then eventually they brought in BTI as well. But because they messed around with pyrethroids for so long, Zika spread up to the mid-beach area, and they began doing control up there as well. But they learned that the ester pyrethroids weren't working, so they tried non-ester pyrethroids. They tried BTI. They didn't bother with a Naled, which was actually smart, and I'll explain why in a minute. So in the first area, Wynwood, these are the trap counts. And I've divided them up into 4 different phases. So initially, you can see that the mosquito counts were high. Andrea mentioned that 10 is sort of the threshold for having a lot of Aedes aegypti, and they were coming in around 18 to 20. Then, after the first attempt at knocking them down with organophosphates, they brought them down to below 10 for the most part. They got lower yet, and then they rebounded a little bit. And let's see why they followed this pattern. So this is a busy slide, but I'll take you through it. So these blue dots up here at the top, those were applications of pyrethroids, lots of different pyrethroids, by the way. They tried everything. And as you can see, looking at the counts of mosquitoes, pyrethroids did not do a thing. And this is not surprising if you know our mosquitoes, because most of them have sodium channel mutations that confer fairly high resistance against pyrethroids. And the prevalence of these mutations are fairly high in Miami. Then they brought in the organophosphate. So here's the first nailed spray, and it really knocked down the number of adults. And they were quite encouraged by this. They tried it again a few days later. They knocked them down just about to 0. And you might think they'd won the war, but then the mosquitoes kept recovering. Every time they'd spray them, they recovered. But these green bands here, these are the applications of BTI, and I've feathered them because BTI loses its effectiveness in a hot, humid climate after 1 to 2 weeks' time. But they ran BTI even after they stopped the adulticides. And then they stopped using BTI, and you can see a little bit of rebound in the mosquito population. So I think the message here is that pyrethroids do not work in Miami. Nailed kills mosquitoes, but doesn't hold them down. And I think there's some reasons for that. And I also have reason to think that killing mosquitoes is not the same thing as controlling arboviruses. That the females who are infected tend to have taken a blood meal and they hide, so you're killing all the newly emergent females, but you're not necessarily killing the ones that have the virus. But this lower area here and the rebound really implicate BTI as being the thing that's most effective at controlling urban Aegypti. And we'll see more of this when we get to Miami Beach. So if we had this nice built-in experiment here, what you can see is in the areas where they ran nailed only, that the population rebounded, but where they combined it with BTI, they held the population down. So that's a very convincing demonstration that that BTI is important for controlling urban Aedes aegypti. Come on, computer. All right, so let's go over to Miami Beach. And they began applying pyrethroids in Miami Beach. It really didn't do anything. They brought in nailed, and I didn't think it was going to work in Miami Beach because of the structure of the buildings and the winds coming in off of the ocean. And indeed, it didn't appear to do much. It didn't appear to do anything, in fact. But then they finally got the trucks in. They had to acquire the trucks and the blowers, and the population went down and stayed down. It looks to be very effective, and I'll break down these numbers in a minute for you. So let's just look at the data during the decline, and it fits very nicely with a regression curve, a very tight fit. But if you look at the particular days where they applied the organophosphate nailed, on that first one, there's no decline, and in fact, it's higher the next day. The second one, they get a bit of a knockdown, and it's again above the line the next day. The third one, there's no effect at all. And the fourth one, there's maybe a little bit of a knockdown. But just the bouncing around of the line, whether or not they're spraying, doesn't suggest that the organophosphate is really doing anything. So let's look at this a little more carefully. We'll look at the residuals. That is what happens. Look at the data after you subtract the regression line. And again, compare that with the organophosphate application. This application here, the first one, essentially there's residual is 0. The second one has a negative residual, but it's higher the next day. Third one is 0, and the fourth one is pretty close to 0. So it really does not look like the organophosphate is having any effect. And if we do a comparison, we look at the day after an organophosphate application and subtract the day before, which is going to show the change. What you see is there's actually an increase with the first one, a decrease with the second one, somewhat of a decrease with the third, and a little bit of a decrease with the fourth. But the first three of these are not statistically significant. You get a statistically significant, decline the fourth time you use it, but you get statistically significant increases and decreases just randomly with no applications whatsoever. So mosquito populations do fluctuate dramatically on their own with no intervention whatsoever. So it's hard to tell the natural fluctuation background from the adulticide applications, at least on this site. So I just wasn't, and I'm still not convinced that there was any effect of the organophosphates whatsoever. But the BTI had a really dramatic effect. So that's the take-home message from Miami Beach. No effect of adulticides, and declines followed the prolonged use of BTI. But there's something I wanted to look at in these data. And what a lot of adulticiding studies that have looked very carefully at the data have found is that after you adulticide, there's a rebound in the mosquito population. And so this is just a little chunk of the data from Wynwood, but it shows something pretty interesting that I wanted to bring to your attention. So after these two adulticiding applications, there was a significant knockdown of adult female Aegypti. And I think that's a pretty robust effect here in Wynwood. But what's interesting is that 2 to 3 days afterwards, you get a very significant increase. And in some cases, the population is even higher than it was before you sprayed. And that's really counterintuitive. I mean, if you're killing mosquitoes, like how are they coming back even higher? And so this observation of the rebound effect is not a new observation. It's been seen a number of times, and people have proposed an explanation, and they've suggested that there's release from larval competition, that the adulticide is maybe killing the small larvae and allowing the big ones to grow faster, and that's why you get this rebound. But it doesn't work, and it doesn't work for two reasons. First of all, in an area like Wynwood, that is the dominant mosquito. There's no competition from other species. But more importantly, if you know the life history of Aedes aegypti, they spend in a warm climate like Miami about 2.5 days as pupae. And so they're not in competition with other larvae. They've already eaten all they're going to eat. And so these mosquitoes that are rebounding were pupae during the spraying. So they were not affected, and they were not released from competition. So there has to be something else going on. And I've looked at all the various possibilities, and one of the things that seemed possible, and I'm wondering, I've got my screen. I don't know about you guys, but my picture here is showing just let's see if I can fix this. My picture is blocking part of the screen here. Can anybody, do you guys just have me up in the corner, or is it?
Well, we can see your PowerPoint slide, but we don't see any pictures. But the PowerPoint slide with your graph
Okay.
are those things.
Oh, good. Okay, good. All right. So one of my students and I did an experiment. We figured out the dose of permethrin, a pyrethroid, that would not kill spiders. And so we went out and sprayed that on a lot of spider webs. We removed the spider, sprayed it on the web, and then an hour later we damaged the web. And orb weaving spiders typically take down their web at night. They leave up the main lines, and they take out the spiral mesh, and they eat that and then reweave it. And we did so. We had control spiders that just got the acetone carrier, and we damaged both sets of webs. And then we came back 24 hours later, and we looked at the web, photographed it, and we saw that the webs were relatively impaired in the spiders that had received permethrin. And then we took mosquitoes in an aspirator and shot them into the web, and found that the catch rate was extremely low. These are the ones that got permethrin. So essentially 100% catch rate in the controls, and about 25% catch rate in the non-lethal permethrin treatments. And so what we think is happening here is that we go back to that rebound, is that we've probably impaired the spiders, the urban spiders that are living under the eaves of buildings and in the bushes around buildings, that are naturally catching a lot of Aedes aegypti. And having impaired those spiders, there's much lower mortality. And that's what's accounting for the rebound in adults, not larval competition, but in fact, release from predation. And people never correctly estimate the number of spiders in an urban environment, but particularly around houses, they're up under the eaves of the buildings, and they're just in every little space. And these are the spaces Aegypti like to hang out. So we don't know for sure. We haven't done the definitive experiment yet, but we think it's very likely that the adulticides are incapacitating the predators. And that's what's allowing the rapid rebound of urban mosquitoes after an adulticide application. Of course, with BTI, that's not a problem. So the takeaways that we got from this study is that, first of all, that BTI greatly depresses the urban Aegypti population over a period of weeks. And in South Miami, where I was the mayor, we asked the county to come in and begin doing prophylactic BTI applications at the beginning of every summer, which they've done. Now, I have two little asterisks, and that's a reminder to myself about two things to think about. One is, as Andrea pointed out, in Key West, they got about 70% control. And part of the problem they've had in Key West is that there's a lot of cisterns where people used to keep water, particularly, and they're still there, and you can't reach them with aerial BTI application. And likewise, hot tubs are popular, at least in the wintertime, but in the summertime, they've got a cover, but of course, Aegypti can get in, but the BTI doesn't get in. So there's just these pockets of water that are hard to treat from the air, and that may be harboring that other 30%. The other thing's a little note, and that is that you should not be breathing the vector-back WG. That it's not toxic to humans, but the particulate matter is just something that people should not be breathing. So during the actual dusting, it's good for people who are outdoors to wear a dust mask. Everybody's got masks now for COVID. That's great, but don't go breathing this stuff directly. It's not going to poison you, but it's not going to do you any good. And we had a number of people who were out jogging when it came by, and they were very sorry that they hadn't taken cover for a couple minutes to let the stuff settle. But other than that, it's, we've been extremely happy with it. We find that the adulticide effects are transient at best and ineffective overall. And we think that that predators are likely the reason, impairment of predators is the reason for the rebound that's typically seen after adulticide applications. So that's it. And if there's any time, I'll take questions, or we'll just pass it off to the next speaker.